Hello, this is FlippedHarber for Precalculus. In this video we'll be covering section 4.1, one-to-one functions, inverse functions. Our objectives for this lesson are to determine whether a function is one-to-one, obtain the graph of an inverse function from the graph of a function, and find the inverse function. Our topics include functions, one-to-one functions, and inverse functions. The outline for this video will talk about one-to-one functions, the horizontal line test, inverse functions, graphs of inverse functions, and finding the inverse function. Now, we all know what functions are. Here we see several graphical representations of the idea of a function. We see some domain and ranges. These are what we refer to as mapping diagrams. We see a couple graphs. Now these are all functions because every domain value points to only one range value. You don't see a double arrow coming off of the domain, and both of the graphs pass what's referred to as the vertical line test. Now not all of these are one-to-one functions. A one-to-one function takes it a step further and says that not only can the domain not point to more than one range value, but not more than one domain can point to a particular range. So we see in the top mapping diagram, every domain points to one range, but every range is only being pointed to by one domain. In the bottom mapping diagram, both the -1 and the 1 value in the domain point to the range value 5. So that is not a one-to-one function. Looking at the graphs, they're both functions, they both pass the vertical line test, but they're not one-to-one functions. We can see that a couple x values create the same y value. So those are not one-to-one functions. A quick way to do this graphically, if you've got the graph of a function, you run the horizontal line test. If every horizontal line intersects the graph of a function f in at most one point, then f is a one-to-one function. So we see that the top function, which is actually our x squared function, does not pass the horizontal line test. The bottom one does, which happens to be a variation of the x cubed function. So when they pass the horizontal line test, they are a one-to-one function. Now, this brings us up to inverse functions. Let f denote a one-to-one function, so it's got to start out as a one-to-one function. The inverse of f, denoted f with a -1 power, that's not really a -1 power, it's just our notation that means the inverse, is a function such that f inverse of f equals x for every x in the domain of f. And the opposite has to be true. F of f inverse of x also has to equal x for every x in the domain of f inverse. Now, something interesting to point out is that the domain for f is the range for f inverse, and vice versa. The range of f is the domain for f inverse. So our function f changes our domain values into our range values, and then f inverse does the exact opposite. It takes those range values, becomes the domain, and it turns them back into our original domain values. Now, when we look at the graphs of inverse functions, this is really a handy idea when we want to create the graph of an inverse function. The graph of a function f and the graph of its inverse are symmetric with respect to the line y equals x. So here we see two inverse functions. They're both one-to-one functions. We see the y equals x line in green, and every point on the inverse function is a mirror image across the line y equals x. So the point 0, 1 is on the blue curve. The point 1, 0 is on the red curve. They're inverses, and that's true for every single point. Now, if we tried to do this with functions that aren't one-to-one, something like f of x equals x squared, you can see that when you reflect it over the line y equals x, your inverse is not a function. That's why we limit ourselves to one-to-one functions, so that when we take the inverse is itself another function. Now, when we want to algebraically find the inverse function, all we need to do are switch the x and y values and then just solve for y again. You've done this before. You should have done this in Algebra 2. So let's go ahead and find the inverse function for f of x equals 4 over 2 minus x. My first step is to replace the x and the y's, and now I'm just going to go through the algebra to solve for the y. So I will multiply over the 2 minus y, I'll divide over the x, subtract the 2, and the last thing I need to do is just change all the signs so that the y is positive. So I have y equals negative 4 over x plus 2. Now if they wanted me to find the inverse of this, I should probably change it to inverse function notation. F inverse of x. We'll do that on the next one though. So here's another one to try. No matter where the x's are, change them to y's and make it x equals 2y minus 3 over y plus 4. Now I'm going to multiply over the y plus 4 so that everything's on the main level of the function. Distribute my x, and now whatever has a y I'm going to get on one side of the equal sign. Everything that doesn't have a y is going to end up on the other. So I move the 2y over, I move the 4x over. Now the reason I did this is so that I can factor out my y. Now I just need to divide by x minus 2. And I'll write it in inverse function notation. Okay, so that's really all there is to this section. You've done almost all of this before in Algebra 2. It's time to get to work. I'll see you in class and I'll see you online.